Okay. I had a couple people ask me to record today, so.
Can I hear you?
What? Can you hear me? If that's moving, that means that you hear my voice.
Whoa.
So now, as we go through here, we're gonna do some problems. I'm gonna move this over to the other side.
Can they see you?
They just see this screen. They hear anything you say, so don't say anything you don't want to hear. A survey by the National Retail Federation found that women spend, on average, $146.21 for Christmas holidays. Assume the standard deviation is 29.44. Find the percentage of women who spend less than $160. Assume the variable is normally distributed. Okay? So, $160. I would guess most you spend more than that for Christmas.
Yeah.
So, but here's what I have. Here's the average. Correct? If we're looking at this data right now, 146.21 is our average, right? We want to know what percent of people spend less than 160, right? What do we know our percentage is going to be?
50%.
At least 50%,
At least.
right? Because it takes up half the graph already, correct? So it's going to be probably 60% or something along that line, right? But we don't have in our charts the one table E that we used last night. We don't have a value of 160 on there. So what we're going to do is we're going to change this to a Z table. And so what we're going to do is find the Z value. Now if you remember the Z value here, remember this down. Oops, I'll just go this way. If you remember the Z value formula is X, the value I'm looking for, 160, minus my mean, divided by standard deviation. That doesn't change. So on here it's 160 minus 146.21 divided by standard deviation of 29.44. Was it? It gave us that in the problem.
Oh.
So in the problem back here it says the mean is 146.21. So I found my Z value. My Z value is 0.47.
Wait, how did you find the 29?
They give us that in the problem too.
And the 146 would be considered 0, right?
The 146 is 0, that's right here. So on this chart here, this is going to be 0. Now my Z value is going to be 0.47 here. Okay? So now we got the Z scores, and now we're going to go to table E in the back of the book, or table E on your charts if you have your charts in front of you. Now if you don't have a chart yet, because Stephen didn't get them all made, if you don't have a chart yet, go in the back of the book. This table E is in the back of the book too. Yeah, so it's on page...
So that's the Z score you found?
Yep, that's the Z score I found. All these charts are in the back of the book. Table E is on page... And down the line, we're going to... 770. Down the line, all your tables that you're going to use are not on here. So we're going to have to use some tables in the back of the book. So 770 is the one... On page 770 is the one in the back of the book. So if I go to table E, I need 0.47. So I'm going to go down to 0.4. And then go over to 7, and so I have 0.1808. Okay, we follow.
Yes.
You have to add 0.1.
0.4. Yeah, 1808. So this area right here is 0.1808. Then I got 0.5 here. So I got 0.6808. Correct? So the question comes in here, it says find me the percentage, I think it's the question asked, find me the percentage of women that spend less than $160 for Christmas.
68.1%.
68.1, I think 68.08% of women, right? Now let's add the question. Let's think about, I know this was one of the questions you're going to have in your homework. Let's say I add one stipulation to it. Same question, read out the same way, right? But the question was going to ask at the end. Given that I asked 1,000 people, what's what you did? 100 people. 100 people. Approximately how many of those 100 would spend less than $160? Yeah, times it by 68%. 68 times 100, you get 68 people, right? So approximately 63 people. Yeah. Now think about how a consumer, a business, would use that. Christmas sales. You know, you got your Christmas sales here. You know that on average a person's going to spend this much money and you say, okay, today they're expecting this many people in the mall. I'm gonna get, let's figure I get 150 people, on average they're gonna spend this much money. You can project how much sales you're gonna have in your store. At the same time, that projection will lead to how many workers can you afford to put on staff? How many workers can you pay their wages? Now, I think I talked about in here the ratio like on Menards, right? I think I talked about that in here today. That's the same thing. They got a projection. This is how many people are going to come to the store today. This is the ratio we need. That's all we do. That's all we do. This is the average on a Saturday what we can do. So they're using these values. Try another one. Let's take that one. They'll read it. Each month, the American household generates an average of 28 pounds of newspapers for garbage. What is that? Assume the standard deviation is 2 pounds. If the household is something that kind of 5,000 will generate 27 to 31 pounds per month, assuming the value of variable is approximately. And you can tell this book. Is this book old? Yeah, you can tell this book is old. Would you say 28 pounds is pretty high? A newspaper a month? I would probably, now if they said newspaper and junk mail, I probably say pretty close. Yes, newspapers, I don't think that people buy that many newspapers anymore. It's online. You might have a few magazines, but I think it's a little high. Here's my average, 28. Right? Look at a little bit below, a little bit above, right? But these numbers aren't the ones we want to use. We want to base it on 0, right? So what do we have to do? Twice. We have to find 2 z-scores. We have to find this z-score for this value, and we have to find that z-score for that value, correct? So go find it. Find both z-scores. So you're going to take 30, like, I'll do this one for you. You're going to take 31 minus 28 divided by 2. It's your value minus your mean. Value minus your mean. Divided by my standard deviation. Okay? So 31, the second one, 31 divided by 28 divided by 2 is 1.5. First one. Is it? 27 minus 28 divided by 2 is negative 0.5. Now you have to find both areas. So first area we're going to do, let's just do that 1.15, right? So you're going to go to your chart and look up 1.5. Now somebody said, well, where did I go over? It's 1.50. So if I was looking at the chart, it would be 0.4332. 0.50 this column. So we got this area right here. Here's 0.4332, I believe I said. Now the other one is a negative 0.5, so it's going to be 0.50, correct? So I got 0.1915. So I got those two. So I said look at those and I say, what would I take? I got a little area on one side and a little area on the other side. I know both areas. What I'm going to do with this? Add them together. So if I add those together, it looks like I get about 62.47%. All the people are between these two values.
Why don't you just run it up to 60?
I could go 62.5. I'm not too worried. What was the rounding we wanted? The z-score was 2 decimals, correct? I usually go 2 decimals on the percentages. The 2 that go on one side, so like on here, I'd go 62, and then 0.47. Because you have all the values in the chart. Okay? It's pretty nice to have the values in these charts. I remember doing this was a long time ago. I remember doing something like this. But ours was, I believe our chart was made like 0, 1, 2. That's all we did. So what we had to do was follow the presentation. So lots that work for us. One more, I think. Let's look at that one. American Automobile Association. Report. Reports that the average time it takes to respond to a new Sioux call is 25 minutes. Average call to Sioux call is 45 minutes. Assume the variable is approximately normally distributed and the standard deviation is 4.5 minutes. If 80 calls are selected around approximately how many will respond in less than? Now, first of all, you think that's use yourself. 45 minutes. Use. Okay, if I was looking at this thing, first of all, we need to do the data. This is the American Automobile Association reports that average time it takes to respond to an emergency call is 25 minutes.
That's a long time.
Rural community or city?
Rural.
Rural community. That's it. City?
Less.
City is really saying.
7-10 minutes, they usually say you get the call, right? I thought that, at first I thought this was still for rural, I thought that ridiculous. Two things I didn't think about. Think about when Amy Churchill was here the other day. And she was talking about her time to get to an accident. How long did it take? She said about an hour to get anywhere from one side to the other. It would take her about an hour to hour and a half to get to all favorite areas she tells us. No, when Spildy and I, and this kind of makes sense now, because when Spildy and I stopped in Ferguson that accident on the way back to our knowledge boat meeting, and we had to help the guy out, and we were waiting for emergency crews coming and everything like that. We had nobody show up for 20 minutes. And that was 2 miles up Ferguson. I had to direct traffic, and Spildy was helping the guy out. But that was 20 minutes. We couldn't believe it took that long to get there. But that pretty much falls in this range, actually. Pretty close to 25 minutes. But you have to remember that patrol, state troopers, depending on where they are, yeah, you might get city. City can't go outside of city. You know, it's just certain regulations.
Just 2 miles.
But jurisdiction, it comes down to it. And then you got your county. How big a county is Ottertail? If you're Ottertail, what's the lowest part? Elbow Lake? Down by Elbow Lake? And the northern part would be probably by Wobbin. So you're talking on one side to the other, you're talking over 100-some miles. You know, so that's a long ways to go, right? So plug it in, get your Z values. Get your Z values. Yeah, I got here 15 with my z-score, 15 minus 25 divided by the standard deviation of, what was it? 4.5. Take that, plug those values in. I'm just going to go like this on here, find the z-score. I'm guessing my z-score is a negative 2.22. Okay, negative 2.22. So now what you're going to do is this, when we look at our chart on here, real quick, on our chart, you have this, right? Here's a negative 2.22, and we're finding this area because we want it less than that, right? So if we go to my chart and find 2.22, 4868,
Oh, 2.2.
that is,
2.2.
Oh, 2.22.
that is that area, correct? Because whenever we find an area on my chart, the area on the chart is always from the center out. Center out, right? So we found that area. Now we're gonna take 0.5 minus that, minus 0.4868, and we're gonna get 0.0132. Correct? But now the question said, of these, how many was there? 80. So, in other words, we're gonna take this times 80 then, right? And we're gonna get what? 1 point, can't get my pen right, 05 something. 6. So, if I went back to my question here, and to find how many calls in maybe less than 15 minutes, roughly find this, we have approximately 1 call where we responded within another 15. Not 20, but that makes sense. That person made it because he was less than 15 minutes.
Oh, I mean first.
Okay. So we'll come back to this. What I want you to do right now is on page 303. Let's turn it over to this new here.
So you wanted these quiz points, and I agree. Well, what if we do?
25, 26, 27, on page 303. That's your quiz. 303, 25, 26, 27. 3 columns. Just almost like this.
Anything else or?
Then I'll look up the homework in a second here. I'm going to stop the
We don't
record.
need any more.
Yes, you do.
I